Good afternoon. This is Mark with the Tactical Technician of Diagnation to talk about electronic motor mounts, in particular on a Honda. This setup has a front motor mount that is controlled by the PCM. It has a motor mount solenoid right here, as you can see, that will send vacuum to the motor mount. I believe it to stiffen it up at idle, to give you a better idle. Once you come to 1,000 RPM, the vacuum will go away from the mount and it will, I'm going to say, relax or not be as rigid. Nonetheless, there's a state of change dependent on idle or off idle. It is not about drive or park from the testing I've done, and I will show you. I will let you see it at idle, and then we will go to off idle. We will see states change as far as the way this thing is controlled. Take a snapshot of your illustration. You can see it right there. We're looking at 4 channels. In the lower right, you can see the motor mount. That is the vacuum line going to the motor mount from the motor mount solenoid. There's a manifold feed to the solenoid on its lower port. Its upper port feeds over to the motor mount to stiffen it up at idle. You can see the PCM lower left, that it is ground. The motor mount solenoid is ground side controlled. There's a wire going to the PCM to control. It is not duty cycled. As you will see, this thing is an on or off, kind of like a canister vent solenoid. It doesn't duty cycle or fine tune the motor mount. Newer cars have, I guess you'd call, more intelligent motor mounts. There's a lot of super high-tech smart mounts on cars today, and one comes to mind is the 2005 Honda 3-liter hybrid with active cylinder management. That has motor mounts that have real precision control, because that thing goes from 6 to 3 cylinders anyway. As far as this setup here, we've got 4 channels on the scope. Channel A, blue. We have a WPS 500 on range 2. We are teed in to detect vacuum in that line going to the motor mount. It goes from the intake manifold through the solenoid. At the PCM's request, it will send vacuum to the motor mount. Channel B, red, is the voltage on the control side of the solenoid, which will go high-low, depending on the driver in the PCM, whether it grounds it or not. Channel C, green, is a Steelman chassis ear. I hooked the microphone up to the motor mount to see if you can see any change during the state of change when the PCM turns the mount on or off. In this case, I didn't see any, but nonetheless, we'll take a look at it together and see what goes on. Channel D, that's a black channel. We're on a yellow backdrop. That's the current ramp going to the motor mount solenoid. Anyway, just bear in mind that this thing, from what I've done, read the service information, when I make or break the circuit or disconnect the solenoid, I do not hear any change in the engine. It runs the same either way. Nonetheless, just something to bear in mind. Also, I pressure checked the hose going from the motor mount solenoid to the motor mount. It is intact. It is not leaking. I checked it with a vacuum pump. Okay, so we're going over to the scope. I'll show you the setup here. Here's our amp clamp. There's our Steelman. There's our microphone. There is our mount down there. There is our WPS with our T. We are teed into the control line going to the motor mount. Anyway, this will be hopefully made in one shot. I will show you the scope screen. So I got a little glare today. It's just one of them kind of sunny days. Nonetheless, here we are. We're rolling across the screen. The car's not on. The blue channel is vacuum. Red channel is voltage control. The black channel is current, and the green channel is the microphone. We'll see noise. You saw in one of my other videos when we talked about engine noise. I will start the car and we'll look at changes. I will make some state changes. I will let it idle, and I will come off idle. I will let it come back to idle, and then I will go in the car and I will put my foot on the brake and ship it into drive, and then go back to park, and we'll analyze everything. Okay, here we go. I'm gonna start the car. Take a look. Okay, we're running. Got a little change there. Looks like the PCM did something. I will go and I will give it some I'm gonna check the microphone just to prove that it's alive. Here we go, my tap. That's the microphone. You can see the shot flipping up and we're smoothing out. Okay. Okay, let me give it some throttle. Microphone came off. It's going back on. Okay. Just saw the microphone just I had to rehook it. I'm gonna come off idle. See what happens. Look at that. I'm at 500. I'm gonna go to a second just to get a little slower screen so we can see stuff. Okay. Okay. See the changes. I'm just coming. They say in service information 1,000 RPM was the threshold, but the PCM has some control. Right now it has vacuum applied to the mount. I will go in the car and I will shift from park to drive, foot on the brake, and I'm able to give it one power brake to see if you see any action. Go through it and talk about how I shut the car off. Okay, let's roll back to the first frame and we can see the action that took place while we made some changes. Okay, here's our starting frame. The current, let's talk about the current draw of the solenoid when the PCM has grounded the driver in the PCM. Current's flowing through the solenoid. We're looking about, wow, not much. Okay, about 270 milliamps. That's not a lot. That's not a lot. Anyway, we can see our voltage change. We're at high voltage here when the PCM decides to open the solenoid. We're at system voltage and we drop down to our expected low voltage, a few millivolts. They're about 190 millivolts. Anyway, we can see our vacuum change too. When we can look at what's kind of keying on our blue, that's our vacuum transducer. And that thing elevated. You can see the hitch through the little fine spot there. Looks like the PCM did something or something happened. But nonetheless, there's a correlation between everything. The right here, let's open in on that one. Right here, the PCM closed the driver, the current flowed, and the vacuum made an attempt to go down. The vacuum is pretty much manifold vacuum. It's pretty much spot on. And I'll show you that when we run the cursors. That solenoid opens wide up and it sends manifold vacuum to that motor mount. One thing I'll make note of is we can't ever forget the pintle hump. We can see it right there. That means our solenoid had physically moved, and that's a validation of that. And we see more action here. We can definitely see some of the PCM controlling the motor mount. Whenever there was an RPM change, you can see it goes from, this is pretty much atmospheric pressure in blue. Okay, when you start seeing all that stuff, it pretty much means atmospheric pressure in Pico language. And this is, that's manifold vacuum. That's about, okay, I'm about 10.68, negative 10.68. If I double that, it'll be about 21. That's a good idle vacuum for a Honda. Anyway, that's the vacuum getting to the solenoid. A little bit of a delay there, obviously. The vacuum moves a little slower than electricity. The solenoid, the driver closes, the current flows, the solenoid opens, and the vacuum travels down to the solenoid, to the motor mount. Anyway, we're going down the line. Let's go back to a normal size. We're in the next frame. We see some more action, basically the similar situation. We see vacuum go down, and we see current go up. Current is flowing, the solenoid is working, the PCM's working, and the vacuum is getting from the manifold through the solenoid to the motor mount. Green is right there. I revved it up, and obviously when you rev it up, you'd expect more harmonics, which is expected. I'd like to get it to where we can see if it changes at idle. I want to get it there. Here's where I power braked it. I power broke it right here. You can see that abrupt drop down of vacuum. I'm going to start it up and see if we can get it to kind of come in and out and at pure idle, and to see the effect on that microphone, because I don't believe this mount is working. It's not broken to the point where it's in two pieces where when I accelerate, the engine rocks back at me. This is it's supposed to stiffen up the engine a little bit. Evidently, I don't feel any change when it comes and goes. I don't see anything. The engine idles the same whether vacuum applied or not. But I'm gonna start it up and see if we can see any change in the harmonics in the channel green. Okay, right now we're applied. We can see what we got. Okay, we just turned on. Okay, I'm gonna keep that one. That's a good shot. That's what I was looking for. Let's stop the car and roll back and analyze that one, because that's what I was wanting. I was looking for the state to change kind of on its own without me doing anything to the throttle or the load or anything. It looks like it did so here. Its car started up, then the PCM decided, okay, it's time to close that vacuum. What we got here, look at green. It doesn't have any change. I don't see much in green. It looks the same here, which tells me the vacuum got there, but with the microphone being right at the mount, I don't see any change here. As I said, I disconnected the vacuum line. I'll probably do one more, but we have a drop of vacuum here, and definitely things are working like they're supposed to. The red goes down. Let's take a look at the pintle hump once more. Obviously, there is our pintle hump. Solenoid moved. Our noise, our microphone looks pretty much the same, but nonetheless, let's see if I can do one more test. I'm going to actually pull the vacuum hose off the solenoid, because I don't want to do anything with electricals, because I've been spiking this PC, and then I've had to reset it like 6 times. So I don't want any electricity any spikes from the solenoid to affect the scope. Nonetheless, I will start the car and I will take the vacuum nipple off the solenoid and put it back on maybe every 2 seconds. So our electrical system, our current, okay, there we see it. Okay, I will pull the vacuum off the okay. Don't want to beat a dead horse. Okay. We will most definitely get this guy analyze this. Here's a good shot right here. Basically, the state of vacuum is the only thing that's changing, because all I did was disconnect the vacuum hose. And did it really affect the microphone? I would say not. See, I don't believe this mount is working as far as the harmonics. I've never tested a good one though. Nonetheless, I never had, if I had a microphone, I have a microphone right at the mount, and right here when that transfer changes, I don't see any difference in the harmonics of the motor mount. So I probably have a bad mount as far as the vacuum control, but nonetheless, it still holds together as far as a mount should. It's not broken in 2 pieces. Anyway, I hope you like this video. Please be mindful of motor mounts. They're getting more sophisticated, and if this method helps the industry, that's all good. And anyway, signing off. Have a great day. Take care. Bye bye.